Today you will be able to understand that rigid transformations can be used to determine if two figures are congruent or not. In the future lessons, you will be looking at the two learning targets below. Specifically today, you should be able, by the end of class, to be successful with this specific success criteria. You will decide using rigid transformations whether or not two figures are congruent. Our mathematical practices we will be focusing on is modeling with mathematics on and off the coordinate grid. We will be looking for and making use of structure with figures, as well as looking for and expressing regularity and repeated reasoning with patterns within these figures. Please go ahead and open up your workbooks to page 70. At this time, I would like you to identify all of the triangles here that have been transformed using a translation from triangle ABC. Please pause the video at this time and shade all of the triangles that you can identify that have been transformed using a translation. Once you are done, please hit play to check your answers with mine. You should have realized that the following triangles are a translation of triangle ABC. This one here, this one here, and finally this third one here. All three of these prove that they are a translation. Please remember that a translation means the object has moved right, left, up, or down. If you had shaded in any of the other figures, more than a translation has occurred. For example, if we were to look at the figure just to the right of triangle ABC, we would say this is probably a reflection or a rotation, possibly, of triangle ABC. So please ensure that you have the following three triangles shaded in. If you do not, go ahead and pause the video now and correct your work. For this next activity, we are going to be looking at pairs of shapes, and we are going to determine whether or not they are congruent. Please be sure for each example to explain your reasoning using details. At this time, I would like you to pause the video and attempt problems 1 through 4 on pages 71 and 72 in your workbook. When you are done determining whether or not the two figures are congruent and explaining your reasoning in your workbook, go ahead and resume and press play to see if your reasons are the same as mine. If they are not, you may need to add to your notes or change your notes. So go ahead and pause the video now and try the next 4 problems. Welcome back. Let's see how you did with these 4 problems. For problem number 1, hopefully you realized that these two figures are congruent. We can prove congruency by stating that quadrilateral A, B, C, D has been rotated around D a 180 degrees. And then translated left 3 units, and down 2 units. If you discovered a different way to prove congruency, that is fine. Just double check it and make sure it works through rigid transformations. If you were unable to prove congruency, please pause the video at this time and go ahead and try the rigid transformations that I just shared with you. Let's take a look at problem number 2. With problem number 2, we should have recognized that these two figures are not congruent. There are many valid reasons why they are not congruent. For example, I'm sure many of you attempted using rigid transformations, such as tracing figure EDCBA, and once doing so, you probably tried to reflect, rotate, or translate, and it was impossible to map that figure on to the other polygon. Some valid responses to prove that they are not congruent could be that the first figure has parallel lines, so figure A, B, C, D, E has parallel lines, while figure F, G, H, I, J does not have any parallel lines. Another valid response as to prove why they are not congruent could be comparing an angle measurement, such as in the first figure, angle E appears to be 90 degrees. But in the second figure, there are no 90-degree angles. The same thing can be said, proving not congruent based on side lengths. For example, I could say segment ED in the first figure is 1 unit long. And then I would look at the second figure and I could not find any other side lengths that is 1 unit long. All of these 3 reasons shared with you would be valid reasons as to why these 2 figures are not congruent. So definitely by addressing angle measurements or side lengths, we are proving that these 2 figures are not congruent. Let's go ahead and take a look at problem 3. In problem 3, hopefully you realize that these 2 images are congruent. Again, there's many ways to prove congruency here. A sample response might be that you could have rotated triangle ABC around the origin counterclockwise (90°), and then translated the figure 2 units down, and 3 units left. After doing so, we could say that triangle ABC matches up perfectly with triangle DEF. If you did not use these specific rigid transformations, go ahead and pause the video now and test them. Make sure they work according to what I have written here. Add to your notes if need be. Let's now check problem number 4.
Yay or no? Nay.
Sorry, technical difficulty. With problem number 4, hopefully you realized that these two figures are not congruent. So, how can we prove that these two figures are not congruent? Some sample responses could be that the first octagon is much smaller than the second octagon. Or vice versa. The second octagon is much larger than the first octagon. We can further prove this through comparing side lengths. If I compare NM on the smaller octagon, I can see that that segment is just under 2 units long. If I find the corresponding side to it on the larger octagon, which would be FE, I would say that FE is exactly 2 units long. So, based on comparing corresponding side lengths, we can see that these are not congruent. This is just a few sample reasons why they are not congruent. So please check your reasoning now that you jotted down. And if you do not have something similar to either of these, go ahead and add to your notes at this time. Let's go ahead and continue with the next activity. This activity asks us to think about the same concept. Are these figures congruent? So, based on what we've talked about using rigid transformations, please use details to prove that they are or are not congruent. Remember, your patty paper is accessible, so you go ahead and use it. At this time, go ahead and pause the video and try the next 5 problems on your own. When you are done, you may resume the video and check your work with mine. Welcome back. Let's check problem number 1. Hopefully you realized after applying rigid transformations that problem 1, these two figures, A and B, are congruent. A sample response might be that you could have rotated figure A (90 degrees clockwise) with center at the origin. And then translate the figure 7 units to the right. Please keep in mind, this is just one set of rigid transformations that will map on figure A to figure B. If you have found a different path or a different sequence of transformations, that is okay. Just stop and double check and make sure they still work. What is essential is that we are including all the details when describing our rigid transformations. So if we are talking about rotation, we are saying how many degrees, what direction, and what our center of rotation was, the figure was turned around. If we are talking about a translation, we need to remember the direction and the number of units. At this time, let's go ahead and check the second problem. Is figure A congruent to figure B? Hopefully, after performing several rigid transformations, you realize that no, A is not congruent to figure B. So, a valid reason might be that A has a greater area than B. If you recall from yesterday's lesson, we were able to calculate the area of figures, and we talked about if their areas are different, then no, they are not congruent. So if I were to count up A's area, 1, 2, 3, 4, 5, 6, 7, 8, A has an area of 8 square units, whereas B has an area of 1, 2, 3, 4, 5 square units. Oh, I'm sorry. That should be units squared. Again, units squared. So that is one valid reason to prove that they are not congruent. You could also say side lengths. Certain side lengths are not congruent. For example, side KJ is 1 unit long. And if I were to reflect this image over and translate it, I could try to make the argument that it would correspond to side TU. However, I know that side TU is 2 units long. So those are not congruent. As long as you have a valid reason that talks about side lengths or area, or even diving into the world of perimeter, we can indicate that these two figures are not congruent. Let's go ahead and take a look at the figures in problem 3. Hopefully after you've completed problem 3, you realize that yes, figures A and B are congruent. And we can prove that they are congruent by rigid transformations. A sample response might be that quadrilateral A has been reflected over the y-axis. And then, after the reflection, we translate figure A 1 unit to the right and 1 unit down. If you did not use these rigid transformations, feel free to pause the video now and try it. Make sure it works. If you used a different set of rigid transformations, double check that yours work as well. Again, the key parts of this is that we included all the specific details we needed, such as if we're talking about a reflection, we stated the line of reflection, and when we're talking about our translation, we stated the number of units as well as the directions they traveled. Let's go ahead and check figure 5. Excuse me, I'm sorry, figure 4. Hopefully you realized in figure 4 that these two quadrilaterals are not congruent. So no, A is not congruent to quadrilateral B. Some valid reasons might be that both shapes are quadrilaterals and the side lengths all appear to be 5 units in length. However, the angles are not the same. If you use your tracing paper, you can test that theory. One might say that quadrilateral B is a square with 4 right angles, whereas quadrilateral A is a rhombus. So we said B is a square, and figure A is a rhombus. We can also prove that they are not congruent based on their angles. If we take a look at angles H and J, those appear to be obtuse, whereas G and I are acute, and like we previously stated in figure B, all of the angles are 90 degrees. Please at this time make sure you have a valid reason proving why these two quadrilaterals are not congruent. And if need be, add this to your notes. Let's go on and check problem number 5. Hopefully, after performing rigid transformations with problem 5, we realized yet again that no, A is not congruent to figure B. Maybe you may have tried rotating quadrilateral B around a certain point, such as point S, by 45 degrees counterclockwise, and then translated it left 7 units. Once doing so, angle PSR would match up with angle GHI. But both sides of the quadrilateral are a little shorter than that of quadrilateral A. So the two shapes are not congruent. So we might say after performing or after attempting to perform after attempting to rotate quadrilateral B around point S 45 degrees clockwise, and then translating the figure to the left 7 units, the side lengths are not equivalent. So even though here we are proving that they are not congruent, notice I still included quite a bit of detail to indicate what I did to try to prove congruency. At this time, please add to your notes as needed for these 5 examples. Please also feel free to backtrack and rewind at any time or pause at any time if you feel that I'm moving too fast in the video. Let's recap everything that we learned today. First of all, 2 figures are congruent when there is a sequence of rigid transformations that match one figure up perfectly with another. Second, when showing that 2 figures are congruent on a grid, we use the structure of the grid to describe each rigid motion. For example, translations can be described by indicating how many grid units to move left, right, and how many to move up or down. Reflections can be described by indicating the line of reflection. 2 figures are not congruent if they have different side lengths, different angles, or different areas. Even if 2 figures have the same side lengths, they may not be congruent. With 4 sides of the same length, for example, we can make many different rhombuses that are not congruent to one another because their angles are all different. How do we know if 2 figures are congruent? Well, if we copy one figure on tracing paper and move the paper so that the copy covers the other figure exactly, then that suggests that they are congruent. We can prove that 2 figures are congruent by describing a sequence of translations, rotations, and/or reflections that move one figure onto the other so they match up exactly. Please join me in your book on pages 76 and 77 for the lesson summary. At this time, please read through these 2 pages in detail before you complete your quick progress check. If you have any questions from today's lesson, please feel free to ask the sub. He or she may be able to help you in more detail prior to working on your quick progress check. Remember, he or she cannot help you with your quick progress check, nor can any of your classmates. This is the opportunity for you to show me what you have learned today on your own. When you are done checking all of your work and watching the video, please go ahead, put your workbooks away, and take out your yellow quick progress check for today's lesson. Complete this, and please remember to include as many details as possible when you are describing a sequence of transformations. Refer back to today's lesson and the notes within to help you if need be. Also, when you are done, please remember to rate yourself on the back of this sheet using beginning, approaching, proficient, or excelling, and write a sentence underneath to explain where you are at within our learning target and success criteria.